Alright, so what I'm going to do is I'm going to go over the key parts to a gravimetrical analysis problem. We talked about these in class, but I'm going to go over all the key things you need to be able to do. There's 4 steps to gravimetrical analysis. First step is always going to be calculating the moles of each ion. Remember, when we calculate moles of ions, it's going to be M times L times subscript. That's what we do to get all the moles. So if we look at this problem right here, it tells me I have 100 milliliters of 2.0 silver nitrate, so that's where I'm going to start. So I'm going to start here, and I'm going to go, okay, 0.000 liters times 0.20 molarity, and in this case, silver nitrate is AgNO3, so the subscript there is 1 and 1. So ultimately, what I'm going to do is I'm going to get my concentration of Ag plus is going to equal 0.020 moles. So that's going to be moles of Ag plus. Then when I go to do nitrate, it's the same thing. It's basically the same number. So 0.100 liters. So 0.100 liters times 0.20 molarity means I'm going to end up with 0.020 moles of NO3 minus. So that's the first thing I'm going to start with. So then if I go, the next thing I'm going to do is I'm going to find the amount of each ion as far as calcium chloride, CaCl2. So I'm going to do the same thing. If you notice here, I'll highlight it, it's 100 milliliters of 0.15. So it's the same idea. I'm going to do the same thing. So if I go over here, I'm going to take, for calcium, it's going to be 0.1000 liters times 0.15 times 1, because that's my subscript right there. So Ca, 2 plus moles, is going to be 0.015 moles. Then I have to do chloride, Cl minus. When I look at Cl minus, notice the subscript there is 2, so that I'm going to just change my calculation to 0.1 times 0.15 times 2 is going to give me 0.030 moles. So the first step is to calculate all the moles of each ion, M times L times subscript. Second step is write a reaction using solubility rules, plug the moles in for each reactant. So if I come over here, using solubility rules, nitrate is always soluble, so you're going to put calcium nitrate together, and you should be able at this point to tell that you're going to take Ag plus in this reaction plus Cl minus, and it's going to produce AgCl. Those are my 2 reactants. Well, since those are my 2 reactants, I need the concentration of Ag is right here, and my concentration of Cl is right there. So I'm going to plug them in. So when I plug them into the grid, or the, not the grid, but this problem right here, I'm going to go 0.020 and 0.030. Now, looking at this point, I can compare the number of moles of each. And since the coefficients are 1 and 1, I know my limiting reactant is going to be silver. So that means, since that's my limiting reactant, I'm going to use all of it. So I'm going to use minus 0.020, because I'm using all the moles of this, so it's going to be 0, minus 0.020, because it's a 1-to-1 ratio, which means I'm going to have leftover 0.010 moles of Cl. So this technically is my excess, because I have leftovers, and this is my limiting. Then the ratio is 1 to 1 to 1. That means if I'm minus 0.020 here, I'm going to be plus 0.020 moles there. So I get that done. Now, the next thing they asked me in the problem, or the first thing they asked me was, when I look here, calculate the concentrations of each ion, and it was said, the first question asked, what is the mass of silver chloride that can be prepared? So when I go to find the mass of silver chloride, what I do is I come back over here. It shows me that I have 0.020 moles of AgCl from right here. And I'm going to just put it into a grid. So all I'm going to do is grid it up. Well, I do 1 mole of AgCl is equal to like 143.3 grams of AgCl. So then all I do is I take 0.02 times 143.3 I get like 2.87 grams. We'll say 2.9, two sig figs, 2.9 grams of AgCl. So that's my mass. The last question in the gravimetric analysis is the new ion concentrations. Remember this. We use limiting reactant to solve for mass of the product. Thought moles did that. We did this. Use new volume. Remember, in gravimetric analysis, you're adding two things, 100 and 100 milliliters. So when I go to do this, what I'm going to do is I am going to take my new volume is 0.200 liters. I'm going to have to do it 3 times, one for each ion. So I'm doing molarity 3 times. So my new volume is 100 milliliters plus 100 milliliters on the bottom. So I'm going to start with the first one, the spectator ion. The first spectator ion was going to be nitrate. Remember, I had 0.020 moles of nitrate that didn't react, right? So if I come down here, I'm going to go 0.020 moles NO3 minus. And ultimately, that is going to give me, when I divide that into that, I'm going to get 0.10 molarity of NO3. Bam, done. The next ion is calcium. Calcium is a spectator ion as well. So when I go to calculate the molarity of calcium, the moles was 0.015, so I'm going to divide that into volume. So 0.015 moles Ca2 plus. I divide 0.015 by 0.2 and I get 0.075 is my molarity right there. So I get 0.075 and then molarity. The last ion is my chloride. Remember, my chloride was my excess reactant. So when I go to do that, I take the moles, which is going to be 0.010 moles of Cl minus, divide that by 0.2, and I'm going to get 0.050 molarity of the Cl minus ion. So I've done what I needed to do. I found the moles of each ion. I used the reaction, the net ionic reaction, plugged in the moles, found the limiting reactant, was able to calculate the mass of the product after I had the moles, and then the new volume is 100 milliliters plus 100 milliliters, which leaves me to calculate the ion concentration by just putting in the molarity. The last thing we talked about in class is what would the beaker look like? Because remember, we want to be aware of what it's going to look like. Well, we said the product was going to be AgCl, so you'd have a whole bunch of AgCl on the bottom. You would have calcium 2 plus floating around because that is one of the spectator ions. You would also have nitrate floating around, NO3 minus, but you would also have Cl minus. Cl minus was the excess, has to be shown above. There would be no Ag because it's a limiting, so it's all going to be down there. NO3 is a spectator ion, and so is Ca2 plus is a spectator ion. So that's what the visual example that would be. And that is a complete gravimetrical analysis problem. This is the solution for problem 60 in your book. So you can reference it 60 in your book, chapter 4. Calculate the ion concentrations. Here's the steps, and you're good to go. All right? Definitely need to review